In this lecture, we're going to talk about Matplotlib. Matplotlib is kind of the default standard plotting library for Python. It's been around quite a while, I think since 2004. It's really mature and stable. And, I think most people would agree it's kind of the default plotting library for scientific computing. There are other more modern ones that have their uses, but it's always good to use Matplotlib. And one of the reasons is because Matplotlib can probably create any type of 2D visualization that you've ever seen. Basically it has all the bells and whistles. Although sometimes people complain because to create very extravagant figures, then it takes a lot of commands to do that, and I can't deny that. Sometimes it takes quite a few commands to get the figure you want, but nevertheless, it is possible. One of the things I always like to start off with when I talk about Matplotlib and I say that it is possible, there was big news in 2019 for the Event Horizon Telescope collaboration. We're able to essentially capture the first images of a black hole, and the images that they released, of course, came from the result of analyzing the data, and they did that in Python and produced a figure in Matplotlib. And the figure is here. So the image that you've seen of the black hole is actually a Matplotlib figure. So primarily Matplotlib will be used for two-dimensional plots, although we'll see that it also has some ability to do three-dimensional plots and visualizations. The thing to keep in mind here is that Matplotlib plots always contain axes, which contain an individual plot. This is typically kind of the surface area of a plot. I have a figure coming up that'll talk about that. And figure, which is the final image that can contain one or more axes. So typically when you're talking about axes, you're thinking about the lines or the data on the plot. And this is not to be confused with axis, I-X-I-S, which are the actual coordinate axes on the plot. The next figure helps highlight that. So what the area of the plot here is what you would consider the axes, and in these cases, the red line, the scatter plots, the blue line would all be three individual axes, as shown here, and the figure is kind of the area that surrounds that contains the coordinate axes, the tick marks, the title, everything else. So this figure, it comes from the Matplotlib frequently asked questions, and it just defines a lot of the things that you might want to have control over: the major and minor ticks, the major and minor tick labels, the x-axis label, the y-axis label, the markers for the different types of plots. You can have circles or pluses or diamonds, all different different things like that. You can have a background, grid lines. You can have legend, of course, the title of the plot. And so this is a nice figure that kind of describes all of those things that you might want to have control over. And the nice thing about Matplotlib is you do have full control over everything you see. So you can make the figure look exactly how you want it. So let's start with a basic example. It can't get any more basic than this. We have to import matplotlib.pyplot as PLT. This is the standard import. And, this is the kind of idiomatic way to do it. You'll always see this in Stack Overflow and in other documentation, that this is a standard import for Matplotlib. There are several ways that you can instantiate. So this returns a figure and axes object. As we were talking before, all Matplotlib figures have, images have a figure and an axes object. And this is one way to create that object with the PLT subplots command. You can also create it with figure and other things. And you can use subplots even when your intention is to only create a single plot. There would just be one row and one column. And so in that case, I almost always use the subplots command to instantiate the figures. Again, that returns a figure object and an axis object. And in this case, all we're going to do is add a plot to the axis object. So in this case, just a couple of numbers, 0, 1, 2, 3, and this is a Python list being input, and they're just going to be plotted against their indices in this case, right? So in this case, you just get a straight line, and we'll set the x-axis label to just some numbers. So here, this pretty plain plot, not much interesting going on. We'll show on the next slide how we can change the plot style a little bit. And so in this case, the only thing we're doing is adding a grid. We do that with the axis grid command. But we could also, set the Y label. We could, go as far to modify the fonts of the X and Y tick labels. Again, you have full control over the way everything looks. We can also use NumPy data, so it's fully compatible with NumPy, Matplotlib is. So in this example, we'll import NumPy. We'll create a range of numbers that goes from 0 to 5 in steps of 0.2. And then we're going to plot basically that range of numbers against itself to create a linear line. And then we're going to plot t squared as a function of t and t cubed as a function of t. In this case, we're also going on and adding some labels that will be used in a legend, as well as setting the X label to T. In the special syntax here, the dollar signs actually render the T as a LaTeX math font. So you can look up more documentation on that, or I have another example later that shows that in a little more detail. We're going to add a grid, we're going to add a legend, and this is the type of plot we get. So the plain plot styles in Matplotlib are just a white background with kind of, the things you've seen so far. There are many built-in styles. These are, special kind of backgrounds and line styles, thicknesses, other things that are set as defaults. And so here's an example of the same, it's the same example we just saw. However, this time we're going to use the style 538. So if you're familiar with the website 538, Nate Silver's website, he has a very particular style of his plots, and so this style was meant to mimic the style of that website. And so that's why you see the 538 there. My favorite style, XKCD. I'm a big XKCD webcomic fan. And, when I first saw this was implemented in Matplotlib, I just thought it was humorous, but I have actually used it. So this is just a comic type font. But it can be useful to draw figures like this, perhaps when you're presenting presentations and you want to suggest that a trend in a data or a trend in a relationship between two variables, but you want your audience to know that it's not real data, that it's just a hand-drawn data or a trend. And so I've actually found some use in using this type of a comic font. Because you rarely want to produce more than one plot or many plots with this type of style. In this case, I've used this with plot XKCD, and that will only apply the style to the commands that you find underneath the with statement. So only, this is an indentation block, just like a for loop would have, or a Python function. And so in this case, it just executes what's underneath that with the styling and then exits and returns to the normal styling. If you'd like to look at all the available styles on your computer, you can run the plt.style.available. And so in this case, these are all the types of styles that are available, and you can basically test them out to see which one you like the best. We've already seen in previous lecture, we've talked about pandas and its built-in plotting capability. Of course, the built-in plotting capability in pandas is very nice to create quick look plots, but a lot of times the styling is not exactly what you want. So in this example, we just read in a data set and then plot the porosity permeability relationship in a scatter plot using the built-in data frame plot command, and we end up with this type of plot. But if we want it to look nicer, or we want to change some of the things with respect to the plot, what we can do is actually instantiate a figure and an axis from Matplotlib, and then we can actually pass the axis as a keyword argument into the pandas plot command. And once we do that, then the pandas plot command will plot porosity and permeability on that axis, and then we get full control, right? So in this case, I've changed the labels to be the Greek symbols, again, through their LaTeX math syntax. So this generates the phi that you see there. This generates the kappa that you see there on the Y label, and then I've added a grid as well. So that's just an example there. A little more complicated example. In this case, I'm using the same data frame from pandas, and I'm actually creating a real subplot in this case, one with 1 row and 2 columns. Then I'm using the data frame built-in plotting command for histograms, and I'm creating 2 histograms, the porosity and the permeability, and passing in the axes that I created. Now this subplots, because there are 2 columns, axis is actually a tuple which contains 2 items. And so what I'm passing in is actually a tuple, and those are plotted against their respective data. And then I have the ability to go ahead and make some changes to that. So the default for Pandas histogram is to put the title at the top. That's not typically what we do with figures or figure labels. So I set the title to empty to clear that out, set the X label to permeability, Y label to number of occurrences, and then just set the Y limit for demonstration purposes to be the maximum of this histogram. Because it's a tuple, I have to access the first axis through its indices, so 0 there. So all of these commands that are applied to the 0th axis are being applied to this first plot here on the left. The next one, the 1 index, are associated with the permeability, and those are being plotted on the one on the right here. And I just noticed that this should actually be porosity. So you see there's a little bit of styling change because of something that's been run later in the notebook, but nevertheless making it interactive. But nevertheless, the label was in fact updated there. So this is a nice reference figure. I got to give credit to this website, Practical Business Python. A guy has a real nice write-up on Matplotlib on that website, and he generated this figure with some data. It's basically some stocks or ticker company information versus revenue. But he labeled then, so this is the final plot that was created through a number of commands, but then he basically labeled all those commands. So in this case, it was created from a data frame called top 10 with using the data frame bar H, kind, this type of command. But he then passes in the axes that he created with the subplots up here. And so in that case, then he can make changes, which, he created this vertical line here. He set some X limits, added a title to the entire plot, other things like that. So I found this really nice kind of summary of the different commands, different things you can do. In this case, on a bar chart, but a lot of the things apply to scatter plots, line plots, other things like that. So we can do contour plots in Matplotlib. In this case, I'm loading in some reservoir. It's a oil and gas reservoir called Nikolic. I'm loading that in from a data set as a NumPy array. In fact, 3 NumPy arrays containing the X and Y positions and the Z locations, which are the depth. Again, I'm going to create a figure and add a contour plot to that and a color bar. And so then that's how I do it with these commands here. So that's a contour plot. Likewise, I can have a surface plot, and this is where the interactivity comes in. So in this case, I have to load this Matplotlib notebook, which makes an interactive plot in a Jupyter notebook, along with some other imports from Matplotlib. And then again, creating a figure this time, adding an axis to it that is a 3D projection. Our Z data has some nans in it. When we create the contour plot, the nans get whited out, so they're not displayed, but it will cause issues in a surface plot. So we're going to set those to 0, just using the standard NumPy fancy indexing there. And then we'll go ahead and create the plot with the X, Y, and Z data again, specifying a color map and no edge colors, and adding the color bar here. And so in this case, you can see the different depths of the reservoir, and we can actually rotate it around within the notebook here using this interactive surface plot. So there's other plotting libraries for Python. All of these are newer, more modern than Matplotlib. All of them can usually create great looking plots in much fewer commands than Matplotlib. But they are somewhat more limited in their overall capabilities. So Bokeh is a great a great plotting tool that's really targeting interactive applications. So it gives you the ability to, say, zoom in on your data and do other things like that. And it's really made for targeting visualizations in Jupyter Notebooks or HTML web pages. So you can generate HTML Bokeh actually generates JavaScript that can be then run in an HTML web page or web browser. HoloViews is a program that's actually, the interface is very similar to Bokeh, but what it allows you to do is actually choose your backend, and you can use either Bokeh or Matplotlib. So Matplotlib, I would often say, is better for creating publication quality, print type figures, whereas Bokeh, again, is more for HTML or web-based outputs. And so HoloViews actually allows you with one set of commands to create figures that can be then chosen to be rendered with either backend, the Matplotlib backend or the Bokeh backend. Plotly is very similar to Bokeh, interactivity, web-based, other things like that. Altair is the newest of the group. A lot of people came to Python from a different programming language, possibly R. R has a plotting package called ggplot, which is based on the so-called grammar of graphics. And Altair is the same. It's very similar. It's based on a Vega, which is also a grammar of visualization. It's a declarative programming language within Python, and it has some really nice plots. So there's links there to all of those different plotting libraries, and you can go and visit those and see the galleries of the different types of plots that each of those can make.